Okay. Sorry about that, you guys. Let's jump back into this. So as I was saying before, right? Remember that we had these problems before where we were giving an expression and then we were given values for the variables in the expression and then we had to plug them in, right? So let's just recap. Everywhere that you see a variable, you write a parentheses. So parentheses squared minus 4 parentheses, parentheses. And then what you want to do is you want to plug in, right? Plug in the value that they gave you for it. So for B, I have a -2. For A, I have a 3. And for B, I have a -2. Just plug it in. After that, we just do the math on it. And once you do the math, very simple. -2 squared, we know is what? 4. -4 times 3, what's that? -12. And then -12 times -2, and negative times negative is a positive. And then 12 times 2 is 24. And after that, you just add 4 plus 24, call that 28. And that's it. Are we good? Remember how to do this? We're just plugging in. Any questions on that? No questions on that? All right. Let's keep it moving. A little bit harder. But who remembers how to simplify, right, a radical? Simplify a radical. Remember what I want. I want the largest perfect square that goes into 108 right here. The largest perfect square. And also it's okay if you can't see that largest perfect square at first. If you can see a smaller perfect square, you can always start with that and keep working your way down till you get to where the larger perfect squares are. Let's take a look. So I have 108. I know that 10 times 10 is 100. So I know 100 is not going to go into that. For 9, I know that's 81. 81 is not going to go into that evenly. For A squared, I have 64. Maybe. When I double 64, I get 128. That can't be it. How about 49? For 49, I double that. What do I get? 80, like 98? Mm-mm, that can't be it. How about 6 squared? 36. If I double that, that's 72. I double that again. If I add another 36 on that, that's it. It's a 36. So this is going to get broken down into square root 36 times square root 3. Right? Add the square root of 36 is just plain old 6 with the square root of 3. So that's how you simplify a radical. You look for the largest perfect square that goes into it. An easy way is to look backwards, be like count down from the number that the first um perfect square that goes into the number that you have. That's what I'm trying to say. So for example, for mine, it was 100, right? Because 100 is smaller than 108. I'm not gonna do 121 because that's larger than 108. I want it to be smaller. But here's what I'm looking for. I'm looking for a perfect square that's gonna go into it a single digit number of times, not a decimal. Not a decimal. And that's how I got this. Questions on that? Anything? All right, let's keep it moving. I have the same kind of question. Same kind of question. And give you a chance to try it. All right, let's take a look. Largest perfect square going into 50, we know is what? Square root 25 times square root of 2. And square root of 25, we know is 5. And then you have the square root of 2. So that'll be my answer. Questions on that? Any questions? All right, let's jump into this. So we want to solve quadratic equations using the quadratic formula. So when we solved quadratic equations in the last section by completing the square, we took the same steps every time. By the end of the exercise set, you may have been wondering, isn't there an easier way to do this? The answer is yes. Mathematicians look for patterns when they do things over and over in order to make their work easier. In this section, we will derive and use a formula to find the solution of a quadratic equation. We have already seen how to solve a formula for a specific variable in general, so that we would do the algebraic steps only once and then use the new formula to find the value of the specific variable. Now we will go through the steps of completing the square using the general form of a quadratic equation to solve a quadratic equation for x. We start with the standard form of a quadratic equation and solve it for x by completing the square. For example, so we have ax squared plus bx plus c is equal to 0, where a does not equal 0. What we want to do is isolate the variable term on one side, right? And then the numbers on the other. Make the coefficient of the x squared equal to 0, right? By dividing everything by a, everything. Then we simplify the equation. So we have x squared plus b over ax is equal to c over a. And then to complete the square, we find 1/2 b over a squared and add it to both sides of the equation, right? So half b over 2a is going to be b squared over 4a squared. Add that to both sides of the equation, factor it out. So we have x plus b over 2a squared is equal to negative c over a plus b squared over 4a squared. And then we want to find the common denominator to the right side and write the equivalent fraction with the common denominator, right? So we're going to have x plus b over 2a squared is equal to b squared over 4a squared minus c times 4a over d times 4a. All right, let's keep looking. So simplify it. We have x plus b over 2a is equal to b squared over 4a squared minus 4ac over 4a squared. And we combine it all into one fraction. So we're going to have x plus b over 2a squared is equal to b squared minus 4ac all over 2a squared, right? Then we want to use a square root property, square root both sides, and we're going to come out with x plus b over 2a is equal to plus or minus square root of b squared minus 4ac divided by 4a squared, right? To simplify the radical, we have x plus b over 2a, right? Plus or minus the square root of b squared minus 4ac divided by 2a. So, right? So we added negative b over 2a to both sides of the equation. So we have x is equal to negative b over 2a plus or minus square root of b squared minus 4ac divided by 2a. Um, Combining it all, you get negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So this formula is a quadratic formula here. This is what we're plugging our numbers into. Okay, quadratic formula. So the solutions to a quadratic equation of the form ax squared plus bx plus c is equal to 0, where a does not equal 0, is given by the following formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. To use the quadratic formula, we substitute the values in for a, b, and c from the standard form into the expression on the right to see to to on the right side of the formula. Then we simplify the expression, right? The results is the pair of solutions in the quadratic equation. Notice that the formula is an equation, right? Make sure that you use both sides of the equation. All right. Give you guys an example. Let you guys try it before I explain it. Mm-hmm. That's the formula you're using. All right, let's take a look. So the first thing we want to do, remember that our standard form, sorry, remember that our standard form is ax squared plus bx plus c is equal to 0. What we want to do is we want to identify a, b, and c. That being said, in our equation, let's look at what a is. A is the number that's in front of x squared. So in our question, our a is going to be what? 2. B is the number that's in front of x. In our equation, b is going to be equal to 9. And c is a number that's just by itself. C is going to
5.
be 5, right? Very good. After we find those numbers, jump straight into the formula. And the formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a, right? Just plug in the numbers. Same way we did before. This is going to be negative of the b, which is 9, plus or minus square root. We're going to have what? 9 squared minus 4 times a, which is 2, times c, which is negative 5, all over 2 times a, which is 2. After this is just a little bit of math, and you're good to go. This is going to become negative 9 plus or minus, what's the square root? 81 plus, and we're going to have 4 times 2 is 8, 8 times 5, 25, 30, 35, 40. Call that 40. All divided by 4. Then we're going to have negative 9 plus or minus square root of, what's that, 121 over 4. And then we know that the square root of 121 is what?
11.
Good. That's what it is, 11. So now I have negative 9 plus or minus 11 divided by 4. So I can set this up into two different equations, right? X1 is going to be negative 9 minus 11 divided by 4. And X2, right, is going to be 9.
Negative 9 plus 11 over.
Perfect, over 4. And then the rest of it is just calculator, right? Negative 20 over 4. Call that negative 5. This one is like what? 10, 11. So this is like 2 over 4. Call that 0.5. Right? And then, right, we're good to go. Like that's the answer. Just box it in. Questions on this? Any questions on it? All right, I'm gonna give y'all a couple minutes. Try this out. Remember, identify your ABC and then knock it out. All right, let's get this. First things first, let's remember what our standard form is. Sorry. Standard form is ax squared plus bx plus c is equal to 0. My goal here is I want to identify in my equation what is a, what is b, what is c. In this case, a is the number in front of x squared, and what number is that? Or y squared, excuse me. What's the number? What number is that? So 3, very good. B is the number that's in front of x. So that's going to be -5. And c is the number that's standing by itself. That's a 2. After that, just jump straight into the formula. All right. So x is equal to -b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right. Plug in the numbers here. Nothing crazy. So this is going to be negative of -5 plus or minus square root -5 squared minus 4a times c. Right? And then on the bottom, I'm going to have 2 times my a, which is 2 times 3. Questions on this so far? Or are we good? All right. So to simplify everything, negative times negative is positive. This is going to be square roots 25 minus, I think, 24 all over 6. So now I have 5 plus or minus square root of 1 over 6, right? So now I'm going to have two answers here. Two answers. X1 is going to be 5 minus 1 over 6. Call that 4 over 6. And then the other one is going to be X2 is equal to 5 plus 1 over 6. Let's call that 6 over 6. Call that 1. Any questions on this? Questions? Okay. Maybe at the end you can box the answers for me. I'd appreciate that. Before we continue, I just want to give you guys a little bit of notes. You can write these down in your notebook. So this is a little how-to. So how to solve a quadratic equation using quadratic formula. Step 1, write the equation in standard form. Standard form is ax squared plus bx plus c is equal to 0. 2, identify the values of a, b, and c. Step 2, write the quadratic formula, then substitute in the values for a, b, and c. 3 is simplify. 4 is check for solutions. Check the solutions. Just want to make a special note. So if you say the formula as you write it in each problem, you'll have it memorized in no time. And remember, the quadratic formula is an equation be sure to start it with x equals. All right. Give you guys a minute. Take a look at that.
Excuse me. Hello?
You got the notes?
Yeah, I was wondering if we're gonna have a final.
Yeah, we do have a final.
When is it?
The final is on the 17th.
17th?
17th.
Hmm.
So
Okay.
next week on the 10, we have our third test, and then we have the final the week right after that.
So we have third test next week. I thought you said like if you pass like two tests, we don't have to take.
It's up to you. I dropped the lowest test.
Or you drop it?
Yeah. I
Okay.
would still try because you don't know. You might do better on the third than you did on the first two, you know?
I still didn't get my results for the second test, so I don't
No
know.
problem. Just come see me in tutoring.
Okay.
If you want, I'll be there tomorrow from 12 to 6. I'll be there Saturday from 3 to 6.
Mm-hmm.
Or if those 2 days don't work for you, Monday I'm there all day from 12 to 8.
All right.
And when you pick it up, you could simultaneously sit with somebody and do the correction same time if you want.
Okay.
Yeah.
All right. Thank you.
You're welcome. All right, let's try this out. So I want to solve this quadratic. I want to solve this by using the quadratic formula. I have x squared minus 6x is equal to -5. The problem is this is not in standard form. Remember, standard form is a x squared plus bx plus c is equal to 0. So what I have to do is I have to move this 5 over. I'm going to add 5 over here. What I do to one side, I must do to the other. So now what do I have? I have x squared minus 6x plus 5 is equal to 0. Now, what do I want to do? I want to identify what is A, what is B, and what is C. A is the number that's in front of the x squared in this case, 1. B is the number that's in front of the x in this case, -6. C is a number all by itself, 5. Then after that, just go straight into the formula. X is equal to -b plus or minus the square root of b squared minus 4ac all divided by 2a. right? And at that point, just plug it in. Nothing fancy. So this is negative of -6 plus or minus square root. Gonna have -6 squared minus 4 times A times C. All divided by 2 times A. Let's do the math on this. Negative is positive, so this is 6 plus or minus square root. This is 36 minus 20 over 2. Let's call that 6 plus or minus square roots 4. Oh, 16, excuse me. Sorry about that. 16 divided by 2. And the square root of 16 we know is, in fact, 4. This is over 2. All right. Could simplify this down further, right? The greatest common factor on top is 2. So I'm left with what? 6. Oh, shoot. 3 plus or minus 2 all over 2. So two answers here. You have 3 minus 2, which is equal to 1. And then you have 3 plus 2, which is equal to 5. All right. And then we could just call this x1, call this x2, and I'm good to go with this. That would be my answer. That's it. Questions, anybody? All right, let me let you guys try one. Remember, I want you to put it into standard form first and then do all the work that you have to do. All right, try that out. Standard form first. Try. Once again, wanted to remind you guys that all homework has been posted. So you guys have the ability now to go in and finish everything. Please take advantage of tutoring. It's okay to go to tutoring and ask for help with your homework. No problem with that. That's more than welcome. I'll be happy to help you with your homework as well if you want to ask me. Only thing when it comes to me is no test corrections, right? Ask any other tutor to help you with the test corrections. That's it. By the way, those of you that are on campus, you know that today's pantry, just reminding you guys. All right. In 2 weeks' time, like on the day that well not well the day after our final, and the 2 days after our final, let me say it like that, right? It's gonna be like the final days of pantry for the year. So if you guys didn't sign up throughout the whole class, you have one more opportunity coming up, and then that's it. I'm not sure what's happening in January. All right, let's take a look. So remember, I have a problem with this question. This question, which is a squared minus 2a is equal to 15, is not in standard form. Standard form is ax squared plus bx plus c is equal to 0. So what am I going to do? I'm going to put this into standard form, and I do that by simply getting rid of this 15. So I'm going to subtract 15 from here, but when I do to one side, I do to the other. So now what do I have? A squared minus 2a minus 15 is equal to 0. And then now, the hard part, I got to figure out what is A, what is B, and what is C. A is the number that's in front of the square term. In this case is 1. B is the number in front of the middle term. In this case is -2. C is the number by itself, -15. After that, jump straight into the formula. X is equal to negative B plus or minus the square root b squared minus 4ac all divided by 2a. All you have to do is just plug it in. So this is going to be negative of -2 plus or minus the square root. This is going to be -2 squared minus 4 times a, which is 1, times c, which is a -15, all divided by 2 times a, which is 1. After that, just do the math on that. Just do the math on that. Negative is positive, plus or minus the square root. This is 4 minus plus 4 times 15. What's that? 60 all over 2. Let's call this 2 plus or minus square root 64 over 2, which kind of sounds like 2 plus or minus 8 over 2. Let's do a greatest common factor up top. So I'm left with what? 1 plus or minus 4 over 2. Let's cancel out these 2's. So I'm going to have two answers. X1 will be 1 minus 4. Call that -3. And X2 will be 1 plus 4. Let's call that 5. And then that's it. Those are my factors. All right. Something else that I'd like to show you guys, right? This is something more for like your future classes, right? Let's say that I have a root. X is equal to 3, for example, like how I have this answer here, right? And I have my other answer, X is equal to 5. Let me scroll back up for a second. Our formula was a squared minus 2a minus 15, right? So x squared minus 2a minus 15. Let's say that you wanted the factors of this. All you would have to do is take the roots and just move the number to the other side. So if I have x equals 3, subtract 3 from here, subtract 3 from here, you're going to get what? X minus 3 equals 0. This is one of your factors, x minus 3. Let's say I had x equals 5. Very simply, just subtract 5 from over here. Subtract 5 from over here. This becomes what? X minus 5 is equal to 0. Yep. Hold up. I made a mistake. This should be -3. This should be positive. That felt a little bit wrong. Okay, now we're good. And this would be x minus 5. All right. So long story short, you can take your roots and you could change them into the factors, right? To me, this is an easier way to factor than the AC method. On your test, I will ask you to give me an answer but I'm not going to demand that you give me the answer through a particular method. So if you like the AC method, go right ahead, do it. If you like the quadratic formula, go right ahead, do it. It's also on your formula sheet. If you rather do completing the square, go right ahead, do it. Right? Give me the right answer. That's all I'm asking you for. Give me the right answer. All right? And also completing the squares on your formula sheet as well. You guys can take a look at that. Let's look at another example. I feel like we kind of get the gist of this. So after this example, I'm just going to make a couple remarks, then we'll move on to another topic. So, this is a pretty example, right? Because it's already in standard form. Remember, standard form is ax squared plus bx plus c is equal to 0. So we're good to go. We're off to the races. All right. All I got to figure out is what is a, what is b, and what is c. Now remember, a is the number that's in front of the x squared term. In this case, is 2. B is the number that's in front of the x term. In this case, is 10. And c is a number, the constant term, all by itself, 11. After this, plug it in, boom, 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 and that's our answer. Let's take a look. So I have x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Just plug in the numbers, real simple, right? So I'm going to have negative of b, which is 10, plus or minus the square root of 10 squared minus 4 times a, which is 2, times c, which is 11, all divided by 2 times a, which is 2. After this, just do the math on it. No pressure. This is going to be negative 10 plus or minus the square root 100 minus, what's that, 88 all over 4, right? So let's call this negative 10 plus or minus square root 12, I believe, all over 4. Now 12, we could break down a little bit more, right? So this is going to become negative 10 plus or minus square root 4 times square root 3, right? Divided by 4, of course, excuse me. And then the square root of 4 we know is what? 2, right? So this is negative 10 plus or minus 2 square root 3 over 4. Let's factor out a 2 at the top, right? So let's call this 2 times negative 5 plus or minus square root 3 all over, let's say 2 times 2. Cancel these out. Final answer, negative 5 plus or minus square root 3 over 2. And boom, you could give me that as an answer if you want. I would take that. Or if you want to separate it, right? If you want to say that x1 is equal to negative 5 minus square root 3 over 2, and x2 is equal to negative 5 plus square root 3 over 2, you could separate it like that if you want. I'll take that as well. Any answer you want to give me. All right. Questions on that? Okay. Do we want to see another example, or do we feel like we get the gist of it? What do you guys think? All right, let's take a look at one last example then. After that, just going to make a couple remarks and then we move on to a new topic. Whoops. Sorry about that. Wrong button. All right, give that a try real quick. Give y'all like 2 minutes to do that. All right, let's take a look. So I have 3m squared plus 12m plus 7 is equal to 0. This is really good because it's already in standard form. Standard form, once again, is ax squared plus bx plus c is equal to 0. I have to identify what is a, what is b, and what is c. In this case, a is the number that's in front of our square term. In that case, it's going to be, in this case, it's going to be 3. B is the number in front of our single term, our, what do we call that? Square monomial term, right? This is going to be 12. And 7 is excuse me, C is the number that is our constant term, 7, right? Now we're just going to plop this into the formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. You guys have this formula already, so don't worry about trying to remember it. So we're going to have negative of 12 plus or minus the square root of 12 squared, minus 4 times a, which is 3, times c, which is 7. All divided by 2 times a, which is 3. Let's do the math on this. This is going to become negative 12 plus or minus the square root 144 minus what is that? 84, I think. Something like that. I think it is, right? It's 21. 21 would be 42. So 84. Yep. That's good. And then divided by 6. Let's do the math on this. Negative 12 plus or minus the square root. What's that? 0. Let's be back just 40. So square root 60 over 6. 60 could get broken down. This would be like square root 4 and square root 15, right? 15 and 15 is 30, 60 up, and then this would be 6. Keep it going. This is negative 12 plus or minus 2 square root 15 over 6. Let's do a greatest common factor of the numerator of 2. That's going to leave me back with negative 6 plus or minus square root 15 over, let's say, 2 times 3. 2's will cancel. So I'll have negative 6 plus or minus square root 15 over 3 as an answer, right? You can give me this. Or if you want to break it up, I'll take that as well. If you want to tell me x1 is negative 6 minus square root 15 over 3, and x2 is negative 6 plus square root 15 over 3, I will accept these two answers as well. Either one you want to give me, I'll take. All right. Questions on that? Okay. Let me just make a couple remarks real quick. Just want to make it known. Okay. So when we substitute A, B, and C into the quadratic formula and the radicand is negative, the quadratic equation will have imaginary or complex solutions, right? So I just want to make that known. And last but not least, real quick, remember to use a quadratic formula. The equation must be written in standard form, which is ax squared plus bx plus c is equal to 0. Sometimes we will need to do some algebra to get the equation into standard form before we can use the quadratic formula, right? So that's like when we were moving the 15 over or whatever. You will see examples of this in your homework. Knock it out. You should be good. All right. And that's that. All right. New topic, new topic, new topic. This is going to be good. So this is for all my radiology people in the class. This is for y'all right here. Introduction to trigonometry. Let's get it, let's get it, let's get it. This is going to be good. All right. So what we're going to start off by doing, we're going to do something called right triangle trigonometry. As you can see, this is a right triangle right here. We have our angle T. Let me get my highlighter real quick. Sorry about that. So we have our angle T right here. So from T, right? From T, the opposite leg, right? Opposite leg from T, opposite being away from, is this leg right here, right? That's the opposite leg from T, right? The adjacent leg, adjacent means next to, the adjacent leg from T is here. And always and forever, the slanted line, the longest line, will always be your hypotenuse, right? So these are the legs of the triangle, right? Longest line, slanted line is the hypotenuse. Opposite the 90-degree angle is the hypotenuse. It's another way to think of it, right? And then I'm going to ask you questions based on which angle it is. It could be this angle or it could be this angle up here. In this case for T, right? Opposite angle T is this leg. Adjacent to angle T is this leg, all right? Adjacent means next to, opposite is away from, okay? So let's go through this. These ratios still apply to the sides of the right triangle when no unit circle is involved and when the triangle is not in standard position and is not being graphed, all right? So to be able to use these ratios freely, we'll give these sides more general names. Instead of x, we can call the sides between the given angle and the right angle the adjacent side, right? So adjacent, again, means next to. Instead of the y, we will call the side most distance from the given angle the opposite side from the angle t, right? So opposite is away from, all right? And instead of 1, we will call the side of the right triangle opposite the right angle the hypotenuse, right? So this is hypotenuse right here, opposite the right angle, okay? So understanding right triangle relationships. Given a right triangle with an acute angle of t, sine of t is equal to opposite over hypotenuse. Let me get the I want to get the triangle right here. Sine of t is opposite over hypotenuse. Cosine of t is adjacent over hypotenuse. Tangent of t is opposite over adjacent, right? I have a little mnemonic to remember this. I say so, ka, toa. This will come in handy for your future classes. All right. You guys have this on your formula sheets already, so you don't have to worry. All right. And that's that. So again, a common mnemonic to remember in these relationships with SOHCAHTOA, formed from the first letter of sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? Whenever I ask you, give me sine of an angle or something, I'm asking you for a ratio, not ratio. I'm asking you for a fraction answer, right? And we're gonna look at that real quick. But before we look at an example, I just want to give you guys a little bit of notes, a little how-to. Okay. So so given the side lengths of a right triangle and one of the acute angles, We want to find the sine, the cosine, and the tangent of that angle. So to find the sine as the ratio of the opposite side to the angle, right? Find the cosine as a ratio of the adjacent side to the hypotenuse. Sorry. Find the sine as a ratio of the opposite side to the hypotenuse, right? Two, find the cosine as the ratio of the adjacent side to the hypotenuse. And three, find the tangent as the ratio of the opposite side to the adjacent side. All right. Basically just telling you SOHCAHTOA again in different ways. Now let's look at an example. Promise you this is not that bad. All right, let me just make this a little bit bigger. Okay. So it says, given the triangle shown here, find the value of cosine of alpha, right? So alpha, one second, alpha is right here. This is my angle alpha, right? And I want to know what is cosine of alpha. But you know what? I'm going to take this up a notch. I'm going to take this up a notch. They want to know what is cosine of alpha, right? Hold up, hold up, hold up. That's not enough space. Let me try that again. They want to know what is cosine of alpha. I also want to know what is sine of alpha. And I want to know what is tangent of alpha. Sorry about that. Let me move that box. There we go. Very simple, right? Cosine is adjacent over the hypotenuse, right? So adjacent, the side length for adjacent is 15, over the hypotenuse, 17. That's my answer. I'm done. That's it. All right? Sine. Sine is opposite over the hypotenuse, right? Over the hypotenuse. That's it. I'm done. That's my answer. Tangent. Tangent is opposite over my adjacent. Oh, shoot. One second. Over my adjacent. And that's it. That's my answer. And that's how you start off with trigonometry. We do sine, cosine, tangent. Is there any questions on this so far? These are all the answers I'm looking for. Just give me a little fraction, boom, boom, and then that's it. Questions on this? All right, if there's no questions on this, I want to let you guys try one. Try this out for me. Just to be clear, right? They're asking you for, get fancy here. They're asking you for sine of t. I also want cosine of t. And I want tan of t. Give you guys a minute to figure that out. All right, let's take a look. Just to be clear, this is my angle T right here. That's my angle T. And I want to know what is sine of T, right? Remember that sine is opposite, right? It's going to be my 7 over the hypotenuse, which is going to be my 25. That's it. I'm done. How about cosine? Cosine is going to be my adjacent. Remember, cosine excuse me, adjacent means next to. This is going to be my adjacent over my hypotenuse. That's my cosine. That's 25. Now my tan, right? Tan is going to be opposite over adjacent. So my opposite over my adjacent. And that's it. I'm done. Is there any questions on this? Anybody? Any questions? This makes sense?
No questions.
Awesome. Awesome. All right. Let's keep it moving. So I did mention earlier that there was two angles, right? So let's elaborate on that just a little bit. All right. So relating angles and their functions. So when working with right triangles, the same rules apply regardless of the orientation, the way that the triangle looks, right? Of the triangle. In fact, we can evaluate the 6. So that we only spoke about 3, but there are 6 trigonometric functions of either of the two acute angles in the triangle, right? In the figure, right? So the side opposite one acute angle is the side adjacent to the other acute angle, and vice versa. Okay, let's talk about this, right? Let's say that I'm working with alpha. This is my angle alpha right here, right? Opposite to my alpha. Remember, opposite means away from, right? So this would be my opposite, right? Opposite from alpha is this leg up here, right? Adjacent means next to, adjacent to alpha is this leg right here. That's the adjacent to alpha, right? And of course, the hypotenuse is the hypotenuse. It never changes. It's the same for everything, blah, 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 right? Let's say I'm talking about beta, right? And by the way, these are just like random names so I can make a point. This is not something that you need to, fully like call every angle alpha and out and every angle beta. Like, no, they're just names right now, just to make a point. All right. So let's say I have angle beta, right? Opposite my angle beta is going to be that leg, right? That's my opposite. So this would be opposite from angle beta. Adjacent, remember, adjacent means next to, right? Adjacent to angle beta would be this leg. That would be the adjacent to angle beta. And that's it. And once again, the hypotenuse is the same. You don't got to change that. Everything works. All right. So we will be asked to find all 6 trigonometric functions for a given angle in a triangle. Our strategy is to find the sine, cosine, and tangent of the angles first. Then we can find the other trigonometric functions easily because we know that the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. right? So let me just say that in words for you guys real quick before I write that out. Give you guys a little how to. All right, so given the side lengths of a right triangle, evaluate the 6 trigonometric functions of one of the acute angles. If needed, draw the right triangle and label the angles provided. Right? That's step 1. Step 2, identify the angle, the adjacent side, the opposite side of the angle, and the hypotenuse of the right triangle. And step 3, find the required functions. So we have sine as a ratio of the opposite side to the hypotenuse, cosine as a ratio of the adjacent side to the hypotenuse, tangent as a ratio of the opposite side to the adjacent side, secant as a ratio of the hypotenuse to the adjacent side, cosecant as a ratio of the hypotenuse to the opposite side, and cotangent as a ratio of the adjacent side to the opposite side. Okay. Let's take a look at this in practice. I'm going to show you how I do this. In this question here, they want everything. Sine, cosine, tangent, secant, cosecant, cotangent of angle alpha, right? Just so we're clear, this is angle alpha. Just want to make that clear. Okay. So let's get this. Let's get this. Let's go here. So let me start off. Let me start off. So sine, actually, you know what? Let me start off right here. I don't have a formula sheet like you guys, so I have to use my mnemonic. So ka toa. Right? So sine alpha, we know is opposite over the hypotenuse, right? Opposite is what? The 4 over the hypotenuse, which is the 5, right? Remember, hypotenuse is opposite a 90-degree angle, right? Hypotenuse is also the longest line, the diagonal line, etc., right? Cosine of alpha is going to be adjacent over hypotenuse. Adjacent is going to be the 3 over 5. Tangent of alpha is going to be the opposite. That's going to be the 4 over the adjacent, the 3, right? Now watch this, right? Cosecant is equal to, or let me say cosecant alpha, is equal to 1 over sine alpha, which is going to be simply just 1 over 4 over 5. And you remember how we divide fractions, right? Keep, change, flip. So that's just what? 1 over 1 times 5 over 4. Call that 5 over 4. So basically, once you know what the sine answer is, flip it and you get the sign for the cosecant. For the secant, secant is 1 over cosine, right? Alpha. In this case, right? Same thing. Just take the answer from cosine, flip it. So instead of 3 over 5, we're going to make it 5 over 3. Cotangent of alpha is the same thing. It's 1 over tan of alpha. So long story short, take the answer from tan of alpha, flip it. 3 over 4. And that's it. That's how we do these, right? An easy way to remember that cosecant goes with sine and cosine goes with secant. I have this saying, it's another little mnemonic. One co, no coco. Write that down. One co, no coco. Right? In each pair, there has to be a co. I have sine, cosecant. You have cosine, secant. You have tan, cotangent. There's one co in each pair, no coco. So I can't do cosine and cosecant as coco. All right. I don't know if that helps, but that's how I remembered it all these years. One co, no coco. All right. Is there any questions on this? Anybody? All right. If there's no questions, I'm going to let you guys try one. This is the same thing. I want everything, right? Give me sine, cosine, secant, tangent, I want all of them, all six. Triangle T. Give me that. Give you guys a minute to do that. Remember, I want all six. All right, let's take a look. Let's take a look. Let's take a look. So this is my angle right here, angle T. All right. Just to be clear. Now, what do I want? I want sine T, cosine T. Sorry. I want tan T. And then I want cosecant T. I want secant T. And then I want cotan T. Not so bad, right? So for sine of T, remember sine is what? Opposite over hypotenuse, right? Opposite, that's going to be my 33, over the hypotenuse. That's going to be my 65. That's simple, all right? Cosine, adjacent. Adjacent means next to. That's going to be my 56. Over the hypotenuse. That's going to be my 65. Tangent. Remember, our tan is opposite. It's going to be my 33. Over my adjacent, which is going to be my 56. Remember, cosecant, take the sine answer, flip it. This is going to be 65 over 33. Secant, take the cosine answer, flip it. This is going to be 65 over 56. Cotan, take the tan answer, flip it. This is going to be 56 over 33. That's it. Any questions on this? Anybody? Does this make sense? All right. Does it make sense? Let's keep going. So now, a little bit of a flip, right? I want to we're going to be doing finding trigonometric functions of special angles using the side lens. So we have already discussed the trigonometric functions as they relate to the special angles on the unit circle. Now we can use those relationships to evaluate triangles that contain those special angles. We do this because when we evaluate the special angles in trigonometric functions, they have relatively friendly values, values that contain either no or just one square root in the ratio. Therefore, these are the angles often used in math and science problems. So we will use multiples of 30, 60, and 45. However, remember that when dealing with right triangles, we're limited to angles between 0 and 90 degrees. So suppose we have a 30, 60, 90-degree triangle, right, which can be described as a pi over 6, pi over 3, pi over 2 triangle. The sides have lengths in relations to s, the square root of 3s, and 2s. The sides of a 45-45-degree triangle, which can be described as a pi over 4, pi over 4, and pi over 2 triangle, have lengths in relation to s, s, and the square root of s, square root of 2s, right? And then these relations are shown below, right? So there you go. So let me elaborate on these just a little bit, just a little bit. So we have two special right triangles. Oh, this is going to be good. I need a nice, you know what? I'm going to do this one in rainbow. We're going to do this in rainbow. So I have two special right triangles. This is one of them, right? In this special right triangle, there goes my 90-degree angle right there, right? This angle, this triangle will be called a 30, 60-degree triangle. Opposite the 30-degree angle, the leg will be 1, the hypotenuse is 2, and then the other leg adjacent to the 30-degree angle will be square root of 3. Very simple, very simple. My other special right triangle, this is my other special right triangle. This is a 45-degree, 45-degree right triangle, right? The legs will be 1, 1, and then radical 2. Okay? Does this make sense to everybody? This is something that you will need to memorize. Because what's going to come after this? I'm going to ask you random questions like, what is cosine of 60 degrees? And when I ask you what is cosine of 60 degrees, you're going to look at the 60-degree angle and you're going to do what? Adjacent over hypotenuse. So you're going to tell me, oh, cosine of 60, that's just 1 over 2. And that's it. What if I ask you what is tan of 45 degrees? It doesn't matter which 45-degree angle you use. They're both the same, right? It's going to be what? Opposite over adjacent. So for me, you're going to just tell me, oh, that's 1 over 1, or oh, that's just 1, and I'll take that. Right? And I can spin this in many different ways, right? I could say what is cosecant of 30 degrees. I'm making it up. Just making something up, right? What is cosecant of 30 degrees, right? Well, we know that cosecant is 1 over sine of 30 degrees, right? Remember that from earlier. So that's just simply going to be 1 over. Let's look at what sine of 30 degrees is. Sine is what? Opposite over hypotenuse, right? So I'm up here looking at the 30. Opposite would be the 1 over the hypotenuse, which is 2. So this is 1 over 2. Now you remember, keep, change, flip. This becomes what? 1 over 1 times 2 over 1. Let's just call that plain old 2, and that's the answer. All right? So this is what's coming next. I'm going to give you a question, and the question is going to have a very specific angle. What is blah, blah, blah of 30 degrees? What is na, na, na of 60 degrees? Or what is whatever of 45 degrees? Right? And you're just going to give me back the ratio, the fraction answer to it. Very simple. All right. You're going to have a homework that's actually going to list out all of these. It's pretty fun. All right. You guys should check that out as soon as possible. All right. So let me do a little how-to real quick. So given the trigonometric functions of a special angle, evaluate them using the side length. So step 1, use the side length shown in the figure for the special angle you wish to evaluate. And step 2, use a ratio of side lengths appropriate to the function you wish to evaluate. You know what? I forgot to mention something because I'm saying all of these numbers, 30 degrees, 60 degrees, 45 degrees. But over here in the reading, we didn't have that. We had these radian measures, pi over 6, pi over 3, pi over 2, pi over 4, etc. Let's talk about now, how do I go in between degrees and radian and degrees? All right, let's start off with degrees to radian. Degrees to radian. Now I'm making this up. Let's say that I have 30 degrees. And I want to transform 30 degrees into the radian measure. All I have to do is I have to multiply this by pi over 180. When I multiply this by pi over 180, this is going to become what? Pi over 6. And that's it. That's the radian of 30 degrees. 30 degrees turns into pi over 6. Let's say that I wanted 45 degrees, right? And I want to change that into radian. You simply just multiply by pi over 180. And then what do you get? Well, we're going to get 45 pi over 180. And then just break it down. Break it down. I could take 9 out of this, out of the top and the bottom. Call this 9 times 5 pi over, pull 9 out of this. Call that 20. 9's cancel out. Let's see, the 5 and the 20 can cancel out and make 4. So this is just what? Pi over 4. And that's it, right? So I want to go from degrees to radian. You're going to multiply by pi over 180. Let's say it's the reverse, right? Let's say I want to go from radian to degrees. From radian to degrees, right? Very simply, you're going to multiply by 180 over pi. That's the magic formula. For example, let's say I have pi over 4. I'm just copying from what I have above. What I want to change this into degrees. So I'm going to multiply this by 180 degrees divided by pi. Pi's will cancel. 4 goes into 4 once. 4 goes into 180 how many times? 45 times. So final answer, 45 degrees. That's it, right? Let's say that I had pi over 2. Now I want to change pi over 2 to degrees. I'm going to multiply this by 180 over pi. When I multiply this by 180 over pi, pi's cancel. 2 goes into 2 once, 2 goes into 180 90 times. So pi over 2 is the same thing as 90 degrees. And that's it. That's how you go from radian to degrees. You multiply by 180 over pi. So let's recap. Degrees to radian, pi over 180. Radian to degrees, 180 over pi. How I like to remember this is almost all the radian measures have a pi in them. So that being said, I want the pi to be in the denominator. That way, when I'm multiplying with it, I'm canceling out the pi's. That's my goal. I want to cancel out the pi's and be left with just the degrees, right? As an answer. Is this clear? Is there any questions on this? Anybody? All right, let's keep it moving. So I have a question here. Let's look at this question. 1 second. Okay, we're good to go. Okay. Evaluating trigonometric functions of special angles using side lengths. So it says find the exact value of the trigonometric function of pi over 3 using the side lengths. So I'll be honest with you, I'm not too good with the radians, right? In radian, I got pi over 3. What I want to do is I want to change that to degrees. So what do? I'm going to take the pi over 3. I'm going to multiply that times the 180 over pi. The pi's will cancel, right? 3 goes into 3 once. 3 goes into 180. What's that? I think it's 60 times, right? Yeah, that sounds about right. So 60 degrees. Okay, now that I know that you want the trigonometric functions for 60 degrees, I'm going to draw my special right triangle. Here we go. In this particular triangle, right, I want 60 degrees. So I'm going to put 60 degrees up top, which means that my other angle down here is 30 degrees. So opposite of 60-degree angle is going to give me square root 3, right? And then hypotenuse will always be 2, and then this will be 1, right? So that being said, right? Here we go. That being said, I want all 6 identities for 60 degrees, right? So what is tan of 60 degrees, which is really tan of the pi over 3? Remember, tan is opposite over adjacent, so this is square root of 3 over 1. Call that square root of 3. I want to know what is sine of 60 degrees. And remember that sine, this is the same thing as sine pi over 3. And sine is what? Opposite over hypotenuse. So opposite, this is going to be square root 3 over 2. Cosine 60 degrees is equal to cosine pi over 3, which is equal to what? Adjacent over hypotenuse. So it's going to be 1 over 2. Cotan 60 degrees. We know that that's going to be what? Cotan of pi over 3. All we're going to do, right? We're going to take our answer, flip it. This is going to be 1 over square root 3. But remember, it's illegal for me to have radicals in my denominator. Rationalize it. Square root 3 over square root 3. Final answer, square root 3 over 3. That's cotan. Cosecant, 60 degrees, right? This is going to be like cosecant pi over 3, which in our case is 1 over sine 60 degrees, right? So take your answer for sine, flip it. This is going to be 2 radical 3 over 3. Boom. And last but not least, right, we have the secant, right, of 60 degrees. Call that secant pi over 3, right? So this is going to be what? 1 over cosine 60, which is 1 over 2. Call that 2. And that's it. That's this whole question right here. Any questions on this? Anybody? Oh, there's no questions. Let me let you guys try one. Go ahead, try that out. All right, let's try this out. Again, not really a fan of this radian stuff, right? So we want to go from radian to degrees. Radian, I have pi over 4. That means that I'm going to be multiplying by what? 180 over pi. Pi's will cancel. 4 goes into 4 once. 4 goes into 180 45 times. So that gives me 45 degrees. That being said, I can draw my special right triangle now. This is going to be a 45, 45 degree triangle where my legs are 1, 1, radical 2. And they want to know everything, right? So we want to know what is sine of 45, right? Which is the same thing as sine of pi over 4, right? Sine is opposite over hypotenuse. So this is just what? Radical 2 over 2. Cosine, let's say pi over 4, just to save paper, is going to be the same thing. Radical 2 over 2. Tan, pi over 4. It's going to be opposite over adjacent. Call that 1. Cosecant, pi over 4. Cosecant we know is 1 over sine. So let's call that 2 sine opposite over adjacent. So radical 2 over 1. Call that radical 2. Secant, pi over 4. Right? Secant we know is 1 over cosine. So this should also be radical 2 over 1. Call that radical 2. And then tan of pi over 4 should also be equal to 1. I'm sorry, I didn't mean to say tan. I meant to say cotan. Sorry about that. Cotan of pi over 4 should also be equal to 1. And that's that. Any questions on this? Oh, what happened to my triangle? Uh-oh. I'm sorry. Hold on. I don't know what happened to my triangle. It just disappeared on me. Let me give that back to you real quick. Boom. 45, 45, 1, 1, radical 2. Sorry about that. All right. Any questions on that? Anybody?
No.
Okay. All right. So let's keep it moving. So we're going to talk about using trigonometric functions. So in previous examples, we evaluated the sine and cosine in triangles where we knew all 3 sides, but the real power of right triangle trigonometry emerges when we look at triangles in which we know an angle, but do not know all the sides. We know an angle, but do not know all the sides. Before we even jump into this, let me give you a little bit of notes, a little bit of how to. All right, so given a right triangle, the length of one side and the measure of one acute angle, find the remaining side. So for each side, select the trigonometric function that has the unknown side as either the numerator or the denominator. The known side will in turn be the denominator of the numerator. Write an equation setting the function value of the known angle equal to the ratio of the corresponding sides. In step 3, using the value of the trigonometric function and the known side length, solve for the missing side length. Okay, let's take a look at how to do this. Whoops. Hold on 1 second. I clicked the wrong button. 1 second. All right, let's look at this real quick. So they want us to give them the value of the unknown side. So they gave us a triangle, right? We have this triangle right here. And then we want to know what is the value of A and what's the value of C, right? So I'm going to recreate this triangle real quick. This is my right angle. This is 7. This is A. And this is C, right? Which means that this would be like leg C, angle A, and then this would be B, right? Oh, I'm leaving something out, right? This is 30 degrees. If that's 30 degrees, then I know that that's 60 degrees, right? Real simple. And remember, we had a special right triangle before, right? Yeah, we had a special right triangle before where opposite the 30-degree angle was 1, the hypotenuse was 2, and then this was square root of 3. So what we could use here now, right, is we can actually use ratios to get our answer, right? Check this out. I'm going to show you something real cool, right? Let's say that I want to solve for C. Say I want to solve for C. It doesn't matter. I could solve for A first. It doesn't matter, right? Let's say I want to solve for C, right? Well, C over 7, right, is the same thing as, say, 2 over 1. So how many people saw what I did there, right? I took the C over here and I put it over the 7. And then I took the 2 over here and I put that over the 1. I made a ratio. You see that, right? And then what do we do after that? Just cross multiply. This times this equals this times this, right? Let's do the math on that real quick. All right. So I have C times 1 is equal to 7 times 2. Let's call that C is equal to 14. That's simple, right? That's what I'm looking for. That's the answer. C is equal to 14. But that's only one of the answers. I want the other answer, A. What's a good way for me to get A? Very simple. Remember this one from high school. A squared plus B squared equals C squared. Just plug it in. A squared, that's what I'm looking for, plus 7 squared is equal to 14 squared. And then just do the math on it, right? A squared plus 49 is equal to, I'm not even gonna lie to you, I don't know what that is. 14 squared, what is that? 196. 196. Then you're gonna subtract the 49 from over there. Subtract the 49. You know what you do to one side, you have to do to the other. So you have A squared is equal to 196 minus 49. It's gonna give me 147. 147. Then you're gonna square root both sides. So we're gonna get A is equal to, right? So that's gonna be equal to what? Square root 49 times square root of 3. And we know that the square root of 49 is what? This will be 7 square root 3. So basically, I'm just reducing the fraction. That's all I'm doing. So what's my A? 7 square root of 3. And that's it. Those are the two answers that I'm looking for. C equals 14, A equals 7 over 3. Is there any questions on this? Basically, what's happening, we're given a blank triangle. We know an equivalent triangle. We use ratios to get one of the legs, and then we use the Pythagorean theorem to get the other leg. And that's it. Any questions on that? No? Okay. Since there's no questions on that, let me give you guys one to try. This is a little bit harder. I'm not going to give you the triangle, but I'm going to give you like 2 minutes to do this. Try this out. Not giving you the triangle. Find the triangle yourself. Try and answer. I want the other sides of the triangle. So if you have angle B, excuse me, if you have leg B, then I want leg A and I want the hypotenuse, for example. All right. So we have pi over 3. Real quick, I want to change that into degrees. So I'm going to do 180 over pi. Let's multiply these out. So I'm going to get, what's that, 60 degrees. So now I have a triangle, a right triangle. One of the angles will be 60 degrees. The other angle will be 30. And I know that the hypotenuse is 20. I want to know what is, let's say, like leg A and leg B, for example. I have a similar right triangle where 60 degrees, 30 degrees, and 90 degrees were all similar. Opposite the 30-degree angle was 1. Hypotenuse is 2. And then opposite the 60-degree angle was radical 3. Very simple, right? I like to avoid the radicals when I'm doing these. So I'm going to do leg A with hypotenuse 20. So A over 20 is equal to 1 over 2. All right. And then what am I going to do after that? I'm going to cross multiply. Right. So 2 times A is equal to 1 times 20. After that, let's do the math on it. 2A is equal to 20. Divide by 2, divide by 2. So I have that leg A is equal to 10. That's it. After that, to get leg B, very simply, we're going to use A squared plus B squared equals C squared. And I know that A is going to be 10 squared plus B squared will be equal to, let me see what C is, 20 squared. And then just go through the math. 100 plus B squared is equal to 400. I'm going to subtract 100 from here. What I do to one side, I do to the other. So what do I have? I have B squared is equal to 300. And then you want to just solve for B. So I'm going to square root both sides. This is going to give me B is equal to square root 100 times square root 3. And we know that the square root of 100 is simply just 10. So 10 square root 3. And that'll be my answer. That's it. All right. Any questions on this? Anybody?
No.
Awesome. Well, that's it for today. Everybody have a great weekend. Remember, we have test 2 coming up on Tuesday. I'm gonna post a review sheet with this week's announcement, and then we'll be good to go from there. All right. If you guys want to pick up test 2, please come see me tomorrow, come see me Saturday, or come see me Monday. If not, I got you on Tuesday. I'll give it back to you then. Okay. All right. Have a great weekend. I'll talk to you guys later.